So for my project, I wanted to work with interesting data. So I decided to use my own data in terms of health and activity data using the Fitbit API. Basically with the project, I wanted to see if there are any patterns or trends between my activity and the weather in addition to routine to say, can I predict how active I'll be, how many steps I'll take on a rainy day versus a Monday or a Tuesday? What patterns can I find in the data? For sources, like I said, using the Fitbit API, I was able to use a existing package that interfaces working with the API in R called Fitbit R to make the requests to the API and be able to pull in that data in a JSON format. Another source of data is to pull the weather data from weatherunderground.com, in which case I built a custom web scraper to be able to pull in different information, the high and low temperature, humidity, wind, precipitation, type of weather events, and then later be able to create additional fields to determine if there was rain, thunder, fog, or snow present on that day. In terms of data understanding, pulling the data straight as a JSON format, I was able to then convert it to a data frame and realize that I'm only working with the date and the step count. And so from that, I used the LibreDate package to add in additional features to give me the day and the number week in the year so that I'm able to tell during weeks 1 through or 2 through 26 I was on co-op and had one particular routine versus over the summer or in classes. In preparing the data, most of the data was pretty straightforward, pretty clean, especially from the Fitbit API. Nothing, no additional cleaning was needed there. Here's the distribution, fairly normal. I then removed a few outliers later on in the process. But in terms of the weather data, I was originally missing 56 values in the precipitation column. And so what I did was I created a model to impute the data, creating a training and validation set, trying to first just figure out what correlations exist with the precipitation, removing statistically insignificant values, and determining that humidity and wind were the biggest factors that correlated to precipitation, with the model having a accuracy of roughly 54%. I was able to impute the missing values. What I did was for values where there were no recorded weather events, as in the type column was blank, that had any values, I manually imputed those as 0. So then I was left with 34 values to run the imputation function on. And so previously row 19 was an NA value, and I imputed the precipitation to be 0 because there was no weather events recorded for that day. Here you can see the value before imputation, row 19 having an NA value but no rain or weather events, and row 22 having an NA value but recorded rain. So when you go down to the imputed values, here again row 22 was imputed with 0.2 inches of rain for that day. Here I remove outliers, which were days where my step count was above 3 standard deviations away from the mean, which were values in the mid to upper 20,000 range. Both before and after removing outliers is a pretty normal distribution of steps per day, with the mean being around 10,000. Just due to the nature of Weather Underground, I wasn't able to pull all of the data for the given for the range I wanted in one batch. So I created a function to retrieve the data from the site given a time period. And so scraping through the XML of the page, getting the high and low temperature, humidity, wind, precipitation, and weather type, which was the column that needed the most cleaning. And so I needed to remove certain columns that had empty strings to get the appropriate range, and then remove new line characters, tab characters, to then eventually parse out the different types of weather events and put those into their own columns as logicals. And so combining each of the columns together, or each of the vectors together into one big data frame, I was able to then call the function for June 2016 to 2017, and then from 2017 June until December, and then combine both those data frames into one large weather data frame with all the matching rows corresponding to the total number of days. Finally, then able to combine both the weather and activity data into the main data frame with all of the step count, day information, and weather information all in one. Once all the data was aggregated into one data frame, it was then easy to just insert it into MongoDB. And so adding it into the collection, inserting the data, and then now on to beginning to create models. For the first model, I created all the data minus the type column to create a model for step count. And so first initially creating the model with all the different independent variables and removing ones that are statistically insignificant and discovering that week carries the most significance. So then creating a model based on step count and week, I'm able to see that it's not a great model with an adjusted R-squared of 0.0356. In further analysis of the fit of the model, I use the Pearson moment and Spearman correlation to determine that there isn't really a correlation between step count and week for the particular data being used right now. Calculating the mean squared error of the model is also a clear indicator that a mean squared error of 14 million is not exactly a great fit for the model. For the second model, I only queried weeks 2 through 26, which was when I was on co-op and had a much more regular routine. So with that in mind, creating the, again, training and validation set and using week and precipitation as the most statistically significant independent variables for step count, I was then able to create the model, which also wasn't great and had an adjusted R-squared of 0.09. And again, to evaluate the fit of the model, the Pearson and Spearman correlations both indicate that there really isn't one, and the mean squared error is less than 14 million, it's only 11 million. Both models being not great, I then turned to a time series regression to then realize by exponential smoothing that there is kind of a cyclic seasonality to the data, in which case a linear regression model might not be the best fit. But, however, after smoothing the data and again creating a new model, I was able to determine that there was a bit of improvement with the correlations in the model. With instead of 14 million for the mean squared error, instead now it's just 3 million. While 3 million isn't great for a mean squared error, it is an improvement, and with the smoothing of the second model while in co-op, there is sort of that seasonality that has been removed because it's only a 6-month period. Looking at the original time series model of the data for the 6-month period, and then applying and tuning the model using different orders of smoothing, 14, 22, and 30 using the TTR package, then able to see pretty clearly this correlation in the data. There is in fact a correlation between week and step count as indicated by the Pearson moment and Spearman correlation, but when you look at the model, it's still not great with an adjusted R-squared value of 0.77. But the mean squared error is the lowest out of the other models I have so far at 312,000. So overall, I don't really have any significant models, but after some transformation of the data, starting to see some improvement in directions where the data could take me. So I think going forward, I'd like to consider the seasonality in the data and consider different models to find out what might be the best fit